Okay, can everybody hear me all right? Good. Okay, just to reemphasize, I'm not a researcher. I'm a practicing forester, and that's what I do. So what I'm going to talk about really is how to put some of this stuff on the ground and why we do that. So I'll go through a few introductory slides here, and then I'm going to go through a little bit about silviculture and what it is and different silvicultural methods. And I'm going to show an example of utilizing a particular method that applies some ecology to come up with your stand densities, residual densities, and then a little bit on monitoring. You've heard a lot about why we're doing this. Well, across the West, we have vast acreages of Pinyon-Juniper. In the 5 southwestern states, it really becomes it's really the dominant forest type cumulative across those 5, and across 3 states in particular, it's the dominant forest type. So it's really important as far as our landscapes go. So we've had a lot of vegetative changes over the last 150 years, both introduced by our activities, as the previous 2 speakers talked to you about, and some natural environmental changes. And at the same time, we've got more and more people out west, and they're building homes more and more fire-prone areas and putting themselves at risk and costing agencies and all the taxpayers money for fire suppression. So that's some of the reasons for why we're doing things. So really, we don't have a choice not to manage anymore. We need to manage these systems, and the choice will be how we're going to manage the systems. So just a quick definition. Some of you, I'm sure, know exactly what silviculture is, but others of you may never have heard the term. So the Society of American Foresters has this definition up here. In short term, silviculture is basically applied forest ecology. So you're managing forest and woodlands for continued production of forest and woodlands. If you're doing something else, it's not really silviculture. So silviculture systems can be used to maintain a forest and manipulate stand structure, densities, and species composition to meet various objectives. And what I'm talking about largely in doing silviculture prescriptions will be the type of forest woodlands that Peter talked about were persistent woodlands, or something where we want to maintain trees as part of that, not where we want to convert what is now a forest or woodland to a different forest type, a different vegetation type. So I got ahead of my slide a little bit there, but it says the same thing. So non-silvicultural methods would be applied where we want to remove the trees and convert it. So, and again, the decision is going to be based on, it's a management decision based on the ecology and the goals and of the particular landowner, and it should be based on a sound prescription. So. Okay, each stand, we're going to need to have some site-specific prescriptions to do that. So each stand needs to be looked at individually to determine some of the things that Doug talked about earlier. What is the source of that stand? What's the ecology of that site? What is the capabilities? What species do you have on the site? And which species do you want to favor on that site? And then you've got economic and social goals as well. So when you're doing making non-silvicultural methods, you're going to have several factors to consider. Whether it's to be, well, several factors to consider whether you're going to do silviculture or non-silvicultural. So what's the ecology? Is it a persistent or perennial tree site? Do the soils, will they support herbaceous vegetation? And what are the management goals for that site? So here's just some pictures of different types of conversion treatments, chaining, burning, clear cut without regeneration, and mastication. So silvicultural methods are a little different. They stress the retention of long-term sustained management of forested ecosystems. Retention on trees on the site can also preserve your future options, whether that be management options for biomass or wildlife or other reasons. Future decisions, again, based on your projection of your future site, economic, social, and climate conditions. One prescription that's been applied in many places are diameter limit and prescriptions and pruning. These are done a lot of times where we put in fuel breaks. Basically, it means that trees above a certain size are left on site and everything below a certain size are cut. It can be reversed to that, but usually that's the typical in pinyon and juniper ecosystems. Some type of inventory should be done, or understanding of what's on the site should be done when this is applied. I can think of a few instances where diameter limited prescriptions were applied with the intent of keeping a lot of pinyon and a few juniper on the site. And because the prescription was wrong, and the largest trees on that site quite often tend to be juniper, the site ended up being juniper dominated in post-treatment, which was not the desired. And so some caution needs to be taken of that. Pruning of lower branches is sometimes done for fuel breaks. I personally prefer spacing the trees out further rather than pruning them. It's not really something that looks particularly natural in pinyon-juniper ecosystems. Species selection. You can do a species selection cut where you cut in this case, cut all the junipers out and leave the pinyon. And basically you've got, this just happened to be an old chaining that was retreated in this manner. And not by design, but it turned out to be a pretty good pine nut orchard. So, in hindsight. So, this was done before I happened to be on that particular area, so on that district. Restoration prescriptions. We talked a little bit about restoration prescriptions in the last two speakers. Pinyon and juniper sites may need restoration prescriptions, either where the PJ has become overly dense, or it may have expanded beyond what it may have been historically. In these two slides, these stands are side by side. The one on the left is basically an old growth group of Colorado pinyon. Trees are probably about 300 years old. And immediately to the right, well, immediately adjacent, the slide to the right of that, are a lot of young trees that have grown up during recent years with grazing and fire suppression probably being factors. And we have some historic slides of this area that landscape photographs dating back nearly 100 years that depict where there were just groups of trees on this particular landscape. This happens to be over in the Henry Mountains in southeastern and south central Utah. So a fire that could originate in this smaller stand would put the older growth stand, which we may want to retain on site, at risk. So we may want to do some type of silvicultural treatment in there. Restoration prescriptions will also be needed, likely for restoring and protecting ponderosa pine or other forest types where pinyon and juniper have enclosed in around those trees and put those older trees at risk. One of the slides on the slide on the left there happens to be one that a tree that Stan Kitchen back there aged. And it's pushing 1,000 years old, and it's currently the oldest known living ponderosa pine in the world. But if a fire comes through there, the surrounding white fir, Rocky Mountain juniper are going to put fire right up into the crown of that tree, and it's going to be gone. Okay, talk a little bit about even-aged and uneven-aged structures. Typical development of Pinyon-Juniper stands is over time it'll become an uneven-aged stand. And I think Doug's slide in there where he showed a J-shaped, or actually inverse J-shaped distribution of ages probably depicts that fairly well. Usually in PJ stands, once they reach a certain age, all age classes are present to some degree. But you can do even age prescriptions in PJ for a variety of reasons. Fuels may be a big reason around homes or urban WUI interfaces. So you can see the advantages. You got control of site, protection, erosion, horizontal diversity. You can control disease and manipulate species. Your vertical diversity is reduced and doesn't really mimic natural stand development. Uneven aged methods. This is where you would thin, leaving all size classes present, all size classes there. It favors regeneration, protects the site from erosion, maximizes vertical diversity. It's easier to manipulate stand composition, that is species composition. It mimics stand development, and it can give you improved wildlife habitat as well. Some disadvantages. Initially, it's a little bit harder to administer because it's easy for, say, to send out a cutting crew and say, cut all trees below a certain size. Doesn't take much thought. But uneven age, then it's a little bit harder to train folks to do that. And more slides later will show that a little better. Also, small trees are more easily damaged during operations, and disease control might be more difficult as well. Now, stand density index, this is where the science kind of comes in and brings a little bit of the ecology of the species and how you can bring that into your thinning prescriptions. Stand density index is a measure of tree density, and it's based on maximum amount of trees that can be on a site by species, as opposed to other forms of density measurements such as trees per acre. It doesn't, stand density index gives you some idea of relative competition between trees. basal area, unless you know exactly what that basal area, know some more detail is, you can't put those two together. So stand density index can be used to help me the residual stocking guides. So, and we'll talk about monitoring a little later. So stand density index is an index of competitive interaction. And basically we use it as an indicator of carrying capacity of vegetation on a site. So some benchmarks have been developed for stand density index. And these, on the slide here, these were developed by Dr. Jim Long, who's a silviculture professor here at Utah State. I think that dated publication 1985. So in summary, these are some of the ones that he had in his paper there. So at the high densities, above 35% of max SDI, competition between trees affects their growth and vigor. And may see some tree density dependent mortality start developing at higher densities. At 35%, the trees fully occupy the site, and they leave limited resources available for other species. So your understory is not going to be very plentiful there at 3. That's where you're moving into phase 3 of Robin's classification system. At 25%, that would be more of that phase 2, where there's can be both trees and understory vegetation on the site. Trees are starting to compete with each other. So, to these, I've added a few of my own. Okay, at 15% of SDI, so basically trees are not, if they're all spaced out, nice and neat, trees really don't compete a whole lot with each other, and they leave substantial amount of resources available for other species, whether it be grasses, forbs, or shrubs. 5% of max SDI, then we're looking at more of a savanna type condition. So there's reference there. So, okay. There's this is kind of outlined in a little publication I did. That's part of a proceedings that was published in 2008. So, okay, here's just some examples of slides of prescriptions at different SDIs. This is one done at 15% of max SDI. Uneven age prescription done immediately afterwards. Another one at 15%. The previous was in the Pinus edulis, 2-needle pinyon, and this is in Pinus monophylla over in near Nevada. This portion right here is what's been thinned. 15%, and both of these treatments are immediately after, so there's been no growing season or anything after before the picture was taken. Here's one at 5% of max SDI, done in part because of that power line right there. So it leaves basically a savanna type conditions there, where other species besides the trees really dominate the site, but trees are incidental on the site. There's another 5% of max SDI. Okay, I'm going to run through a sample, some sample guidelines that you might find in a silviculture prescription, and talk about some things that are generally considered when a prescription is prepared. So again, you'll need to be site specific when you write a prescription, and look at the ecology and the species that are on the site. So your desired after treatment species mix is going to be dependent on what's on the particular site. On this particular site, you can see it has a fair amount of grass in that understory. That happens to be, I think, button grass. And the trees also have some dwarf mistletoe, as evidenced by the witch's brooms. So on that particular site, tree removal might be an option in that group. So here's some thinning guides using SDI. So the absolute number of SDI for maximum SDI for Pinyon-Juniper is 415. If you put that on a percentage basis, that means that's 100% of the maximum biomass that's going to grow on a site. So if you think about it in that terms, the SDI makes more sense. So if you, for example, if you target SDI to be 20 max, after thinning SDI to be 25% of max, then here's what your stand may look like. If it's apportioned out in 4 different size classes. So you got a max SDI of 26 in each size class. More trees in the small ones, progressively fewer trees as you get larger. And then we got basal area and spacing between trees here. So when I put that into a contract, ask a contractor to go out and thin it, or if I were to send out a BLM crew to thin it, I would break that down probably, and I've just been doing just 3 size classes. So, the note there is when I'm computing, there, went back. When I'm computing these, all right, being very responsive. Push a button and it goes back about 5 minutes later. Hello? If I push it again, it'll do twice. Oh, there you go. Okay. So when I'm computing these figures right here, I'm using this figure to come up with those. But at the same time, I'm using the biggest tree in each size class to do that, which means if everything's done like it's supposed to be done by the contract, we're going to end up with something less than this total figure in the end. So which means it's actually a little bit more conservative, because I'd rather over thin in Pinyon-Juniper type than under thin. And if I was in ponderosa pine or salt timber classes trees, I might look at that a little different. Okay. So that's what that note is referring to there. Okay. This is more of what goes into our contracts. We've got it broken down into 3 size classes. The contractor doesn't even see what the SDI is. All he sees is what I want him to do for as far as target trees per acre, general spacing guides, and I give him a table of spacing guides of various methods. If you're running into an even age group, you use that top. If you're doing uneven aged areas, you're doing this. So, okay, and graphically, if you're looking directly down like an aerial photo on the stand of trees, this kind of depicts that, where here's the crown of the tree, and here's the spacing guide around that tree, and here's how it would fit into spacing, say between a large tree and a small tree. And this would be 15 plus 36 feet. So what's that, 51? So, and then between a medium and a large tree, it'd be even wider. Between two small trees, it's only 30 feet. So gets a little complicated to apply on the ground, but actually they've had several contractors that have figured this out and get it very close. So, and in addition to trait spacing guides, there's some other things that you're going to want to consider. The health of the tree, good healthy formed tree without a lot of disease in it. And if you're in pine nut country, which if you're talking pinyon, you're generally in pine nut country, then you're probably going to want to leave your good pine nut trees. Here's an example of an area that's recently been thinned. You can see there's some trees that are spaced out. There's also some little groups of trees, and there's some areas that basically have some little patch clear cuts that have been done in them, like that one there, up there. So the combination of doing those spacing guides with doing some patch clear cuts and some groups left unplaced leaves a fairly diverse landscape. Some additional considerations, insects and disease. We talked about this a little bit. Mistletoes, black stain root disease, that one's a little bit harder to pick out on the ground. But a lot of times it's, if you have a landscape and you have little patches of trees that are dying, perhaps from beetles, so it's taken the last of it out. But the general landscape is green. Likely those are black stain root disease patches. You probably just want to clear cut around that. Visual resource management. On the left is a native stand. So whether it's expanding due to woodland having been present and removed at some point in time, or it's expanding into areas where woodland haven't been. I don't know on that particular slide, but on the right is a recently thinned stand, and other than these trees right down here in the front, that was a different part of the project where the snow is. It looks pretty similar. So it kind of blends with the native landscape. So in visual. And wildlife habitat opens up a little bit for browsing. Here's an example of Rocky Mountain Elk Foundation's management down in New Mexico. This was a Google Earth image of a pre-treatment slide of a pre-treatment, and you really can't see the small trees in here. This is a treatment area here, right in through here, maybe on this side as well, but mostly on the south side of that road. But there are a lot of small trees, and basically what you're seeing are larger trees that are out there. Here's their post-treatment stand. They didn't thin it. They basically did just left some groups and masticated everything else. So this is an example of something that would be a non-silvicultural treatment. They did not do anything to manage the trees and the groups. They just left them. But they, other than one little patch back here, they thinned. So basically, the explanation I think they had for this one is they left it there because they wanted the hunters to be able to sneak up on the elk. And if they took all the trees out or spaced them out like this up here, then the elk would have too much advantage. So this was a hunter's prescription, I guess. So Okay, Robin's probably going to recognize the slide on the left there. That's one of his. And I'm running short of time, but use of fire in the landscape can be used for, again, for removal of pinyon and juniper. Used during the hot time of the year, it can have unintended consequences like sheet erosion here and downstream siltation of streams. Culturally modified stands. When you see a stand of pinyon and juniper that you don't have to fight your way through and you don't have to duck a lot to walk through, a good indicator that something's going on in that stand at a prior time. This slide's a little deceptive because it is taken kind of with a telephoto lens, so everything's kind of brought in. It looks a little denser than it really was. I actually stuck the wrong slide in there, but when I realized that, it was too late. So, but this may have been a stand that was culturally modified by Native Americans for pine nut production. So, and it's really a quite old stand. So, Ron Lanner gave a presentation in 2008 at the SAF National Convention, and he talked a little bit about use of terminology, using words like invasive versus expansive, encroachment versus maybe expansive too, ephemeral, persistent. Those type of languages you can kind of silvicultural prescriptions really should try to be objective, I guess, and not lead a reader to, or manager to a conclusion. Okay, there are ways to monitor, and I don't want you to read that slide. I want to do that other one. So anyway, field forms can be used that auto-calculate stand density index. And it gives you can fill in trees by diameter class number, and it calculates your SDI and brings it over to another table and sums it to tell you what you have. So,
thank you, Doug. Done.